All right, section 13.5 is now going to lead you into a new world of trigonometry, dealing with things called the law of sines, and then we're going to get into the law of cosines. However, what you need to know about this is the fact that now the triangles do not need to be right triangles. We're so used to trigonometry being all right triangles, but from now on, they do not have to be. Now, first of all, in this video, we're going to talk about using the definition of the word sine to find the area of a triangle. That's our goal in this video. Use the definition of sine to find areas of triangles. Well, what I want you to do is copy down the triangle that you see here on the smartboard, and I want you to color code it if possible. Any triangle that is not a right triangle can be labeled as such. First of all, here are your rules. Number one, capital letters name the angles. Second rule, lowercase letters name the sides. And most importantly, the same letters are opposite each other. So you notice in red I have capital A and lowercase little a. I have capital B and lowercase little b. And I have capital C and lowercase c, which are opposite each other in that triangle with a height of h. That's the way the triangles are going to be used throughout this video and in these two sections. All right. If you're given the measurements for a triangle, and they are in the order SAS. You all know side angle side. If they're given in that order, you can find the area. So I'm going to do one example for you. This triangle right here, example number one, is labeled as such. And you're going to notice that I have in order, I know a side measurement, I know an angle measurement, and I know another side measure. Therefore, I have SAS. They are all in order with the angle, the included angle in between. What I need to do is I want to find the area of this triangle. Well, here's how you do it. You all know the formula for a triangle is 1/2 the base times the height. Well, in this particular problem, we know the base is 2.13. So my area is equal to 1/2 times 2.13 times the height. But the problem is we don't know h. So what I want you to consider is this dotted line, which I'm going to redraw in red, is part of this triangle right here that I'm outlining in red. And we all know 73 degrees is the angle measure that's given. Now, if I wanted to write h in terms of 73 degrees, we could use the sine function because h would really be the opposite side, and 2.96 is going to be the hypotenuse of my red dotted line triangle. So I could write sine 73 degrees over 1 is equal to h over 2.96, which would be my c value. Now, if I solve this and cross multiply, I end up getting h is equal to 2.96 times the sine of 73 degrees. That's what h equals. So I can take what I'm underlining in red and I can substitute it right in there for the letter h. So therefore, my area becomes 1/2 times 2.13 times 2.96 times the sine of 73 degrees. And if you notice, what I have here is there's one side, here's my angle, and here's another side. I have SAS. I've used all three numbers to solve and figure out the area. Well, very simply, if I type that in my calculator, I get an answer of 3.015. And if I labeled these are supposed to be in meters. So this would be meters squared. And I just found the area of that triangle using the definition of sine. Well, let's summarize. So any triangle that you have, any triangle at all, any triangle, oops, spelled that wrong, any triangle, you can find the area using these formulas. Let's say that you are told, let's say you're told little b and little c and angle A. If you're told those three pieces of information, then the area of the triangle would be 1/2 little b times little c times sine of angle A. What if you're told little a, if you know how long little a is, and you know how long little c is, and you know how big angle B is, then the area would be equal to 1/2 times A times C times sine of angle B. You notice there's a pattern here. And finally, what if you are told side A, side B, and angle C? If you know that information, then the area formula becomes 1/2 times A, B, times sine of capital C. Those are the formulas to find the area of a triangle depending on which side angle side you are given.